Today's Daily Dose of Math is a geometry problem from my Secondary 3 geometry course. This is a task style problem. We have a situation where a part is being made, and this part is made by pouring melted metal into a mold. And the shape of the part is part of a cone. We imagine this cone with the height of 16 centimeters, the radius of 5 centimeters, and we imagine slicing off the top. If we slice off the top with a horizontal cut, we're going to be slicing off a smaller cone. And once the small cone is removed from the big one, the piece left over will look like this, although this one is drawn upside down. We're being asked to find the volume of this part. So hopefully it's occurring to you to think of the strategy of finding the volume of the big cone and the volume of the small cone and subtracting. That's what I'm going to do. Part B is asking, what's the ratio of similarity between the volumes of the two cones? Looking at A first, I look at what I have and I ask myself, what can I do right away? It's not necessarily the first step, but I have enough information to find the volume of the big cone because I've given the radius and the height. And the volume of a cone formula is pi r squared h over 3. So our r is the radius 5. And the h is the height 16. I'll solve this quickly with this calculator. Pi times 5 squared times 16 and divided by 3 is a number that rounds to 418.9. These measures are centimeters, so this volume is going to be centimeters cubed. I have started solving my problem, but I have more steps to do. I want to find the volume of the small cone, but right now I don't know its radius or its height. But finding the height is going to be a very quick step, so I'll do that next. The height of this small cone has to be the height of the big cone minus the height of the part. So 16 minus 10 gives us a height of 6. And I'll write that here. Now, to find the radius, I can use the ratio of similarity between the distances of these two cones, because I know the height of the small one is 6 and the height of the large one is 16. So 6 over 16 gives me a ratio of similarity between the two cones. I know the radius of the big cone, so if I put it here, I can cross multiply and solve. 16x equals 6 times 5. 16x equals 30. X is going to be 30 divided by 16, which will be 1.875 centimeters. And I'll write that here. Now I have enough information to do the volume of a cone formula again, but for the small one. It's going to give me pi times 1.875 squared times the height of 6 over 3, which is 22.1 centimeters cubed. The volume of the part is simply the volume of the big cone minus the volume of the small cone. So 418.9 minus 22.1. Which is giving me 396.8 centimeters cubed. Now this is not a perfectly accurate number because I rounded both of these. But if you are careful to use the memory of your calculator, to avoid rounding, it's possible to get a perfect answer with the information that we've dealt with. I've answered part A. Now part B. Part B can be answered two different ways. What is the ratio of similarity between the volumes of the two cones? One is simply to take the volume of, I'll put the larger one on the top. The larger one is 418.9 and the smaller one is 22.1. That gives me a ratio of similarity. It's not simplified, but it is giving me a ratio of similarity between the two. There's another way though, which is to know that the ratio of the volumes has to be the cube of the ratio of the distances. And we already had the ratio of the distances here. In this case, the larger one was on the bottom, and I'm putting the larger one on the top in this answer. So I'm going to flip this upside down. We can say we have a 16 to 6 ratio between the distances. That works for the radiuses and the heights and the slant heights if we need them. But we need to cube that. 16 cubed is 4,096, and 6 cubed is 216. Now I want to know if I can have confidence in these answers, because I use two different approaches to find the answers. And one thing I can do to test how confident I am in the results is I can divide and see whether I'm getting the same answer. 4,096 divided by 216 rounds to 18.96. In decimal form. How about 418.9 divided by 22.1? 18.95. Very close. So I'm starting to feel a lot of confidence in my answer. When we see this question, we think about how there were two very different ways of doing it. And in fact, there was more than one way of doing the first problem as well. Geometry is like that. But the key to doing a task question like this, which can seem confusing and hard to understand when you first sit down in front of it and read it, is find something you can do and do it. Start filling in the situation with things that you know you can figure out. And the more you know, the closer you get to the answer, the easier it is to figure out what to do to get the rest of the way. That is today's Daily Dose of Math. Please like, subscribe, and share.